is talk a little bit about the broad topic, some of the research I've been doing the last few years on recovering subjective belief distributions. So I have a specific paper, which is unpublished, which I sent, which covers much of this and has references to our papers and so forth. But I want to give you a broader review of the work we've been doing on how do you elicit these beliefs in a wide range of applications. And I want to make sure I take time to talk about some of the applications, because I know we'll spend a lot of time here on some very important and subtle theoretical questions, but what we've done is we've developed an elicitation tool, not the elicitation tool. There are many elicitation tools out there, and there are silly wars going on about the best elicitation tool, and there's finger wagging going on about this elicitation tool and that elicitation tool. That's fine. That's what academics do for a living. I have an elicitation tool. It has some strengths, it has some weaknesses, and I'll talk about those, but I want to show you some of the applications, and it's built around proper scoring rules. So in that sense, it's a little bit nicely old-fashioned. This specific work is joint with Eric Alm, but I have many co-authors on all of these other papers, so they've done all of the heavy lifting here. So the focus generally is on eliciting beliefs, and I'm going to focus on proper scoring rules with incentives. We've also looked at so-called improper scoring rules, like linear scoring rules, which are really only improper for special cases such as risk neutrality. But I'm going to focus on a canonical case, the quadratic scoring rule. All of the theorems, particularly in this paper, generalize to the entire class of proper scoring rules. So the theorems in the finite case and the continuous case are quite general. But for practical purposes, let's focus on the quadratic scoring rule. I'm going to talk a little bit about some general methodological positions on elicitation. That's not as pompous as it sounds, because there's, as I said, there are strengths and weaknesses in what I've done, and I want to explain why I'm using methods that I know some of you here, and I know who you are, will wag fingers at. So there's a reason for that. There's a methodological trade-off, and I want you to be aware of the criteria I'm using. The major, it's not a contribution. All we're doing is taking existing theory and taking it to experiments, so it's not a contribution. But the major emphasis here is on eliciting a whole distribution. So we get a sense of your confidence, your precision. And I like the word confidence because there are a couple of very beautiful papers in the cognitive psych literature I'll reference later on the overconfidence topic that have made the same point, that you have to elicit the distribution in order to make any statements about overconfidence. And so we're very much a part of that tradition. So it's not just the subjective probability of a binary event, although we've done some work there. The main question I'm going to be focused on is whether risk aversion distorts responses. And by risk aversion, I'm being completely general here. I'm not just talking about EUT at all, or SEU. I'm going to be talking about rank-dependent utility. Everything I'm doing generalizes to CPT. The problem, Peter, you might have closed your ears, we just don't find CPT in our subjects. That's mainly because we actually use real incentives over losses. Whether we use house endowments, we've used earned endowments, we just don't get it. So frankly, I don't give a damn. Everything I'm doing generalizes to CPT if for some dogmatic reason you think we ought to do CPT. But I'm going to focus largely here on EUT and rank-dependent utility, which we find a lot of. So we find a lot of probability weighting. But I'm saying everything generalizes. So I'm going to focus on the role of risk aversion in distorting responses, and what do you do then to recover the true latent beliefs that are underneath? That's the key question. We find that it does dramatically when you're eliciting a subjective probability. There you've got the familiar result that the risk-averse individual, even if they're a rank-dependent utility individual, will be reporting towards the middle because the idea is they're equalizing the expected payoffs in the two states of nature. So by reporting 0.5, that's a standard result. It's a first-order effect. We get some very interesting results, both theoretical results and empirical results, when we generalize this to eliciting a belief distribution. And I'll cover that briefly. So there's actually some very interesting new results here. We then, in this particular paper with Eric, we show how to recover subjective belief distributions. We have a theory paper, which is just out, showing that that doesn't make much of a difference under SEU. And that's actually an interesting result, and I'll talk about that in a moment. But it makes a massive difference when subjects probability weight in an RDU. So in other words, this is the non-EUT corner of the room. When I know that they are non-EUT, I have to do large transformations of the elicited beliefs in order to recover their true latent beliefs. This is the SEU-EUT side of the room. I know from theory and from some empirical work that I can more or less, and I can document the more or less, I can more or less take your elicited beliefs as your true latent beliefs. And that's kind of a nice result. And I can actually recover the true latent beliefs and make a minor adjustment. But that's the sense of what I'm saying. It's very important that I identify this crowd of non-EUT people, because there's a first-order difference between their reported beliefs and the true latent beliefs. And that's one of the things we're talking about today. I'll then talk, and I want to go through this relatively quickly. A lot of the material I'm talking about here is either published or it's in the article, and it's better read than said, if I may say so. I want to spend a fair bit of time talking about limitations and extensions and applications. In particular, the extension that we're working on now significantly is to multivariate risk belief elicitation, risk perception. So bivariate risk elicitation over mortality and morbidity risks and the correlations between those. Yeah.
Clarification. It sounded like you were speaking of sort of true latent beliefs as if you know what those are, as if that's somehow unproblematic, you know when you've got them. So you don't mean that, I take it for you?
No, what I mean by that is that there is a latent, I'm assuming that there's a latent belief distribution underlying your responses to the scoring rule. I'm seeing your observed choices. The observed choices I need to recover, I need to identify, I need to estimate the latent beliefs under certain theoretical structures, and I'll talk about those, that led you with your risk attitudes to report what I saw. So in other words, the elicitation method by itself doesn't tell me the beliefs. That's the point. But I'm not making, I think, any deeper point than that. But I am making a statement that's conditional on a theory about how you're making your decisions. So I'm going to use some structure in a moment. So let me come to that, and then maybe let's come back to the question. Okay. So here are the two classic where we're praising Savage, so let's continue the praise of Savage. And this is the most important paper that really extends. It's essentially an extension of the proper scoring rules to look at continuous probability distribution. So essentially, our raft of papers here is an application of the ideas developed in this very well-known paper. Here's two methodological positions I want to be clear on. First, I have a strong preference for having a simple interface for subjects. There's several reasons for that, and one can compare it to more complicated methods. A good example, just to back up a little bit, is if I'm trying to elicit risk attitudes over objective probabilities, I prefer to just show people one lottery and another lottery, and there are interesting ways to represent the lottery. That's actually not a trivial issue, rather than use, for example, a Becker-de Groot-Marchak procedure to elicit a certainty equivalent. I fully comprehend, because I was the person 32 years ago that wrote a paper saying you can use BDM to elicit CEs and hence infer risk attitudes. And I'm the first person to bury that method. Subjects just don't get it. Yes, I fully understand. If I know your certainty equivalent, I know the risk premium, I get more information. The problem is you can't get subjects to do it. So, and I'm here to tell you as an old man, I've been doing this for decades, I want simple elicitation methods where the incentive compatibility is transparent to the subject. Binary choice, maybe on a strong day, multiple object choice. Real simple stuff. I'm extremely happy to see mere theorists proposing new elicitation methods. Don't get me wrong. I can tell you the subset of people for whom they might actually work, and I use them: actuaries, chief risk officers, experts. I'm actually interested in eliciting their beliefs. And some of the fancier methods can work for them. And I'll give you some very brief examples later. But in general, I want a very simple interface. The attraction of this is it's easy for subjects to figure out what to do. You don't have lengthy instructions, just place a bet. It's relatively easy to take to the field with less literate subjects. So a lot of the work I do in the lab, and everything no, that's actually not true. About half of what I'm doing here today is in the lab and half is in the field. I always wind tunnel stuff in the lab. I never go to the field until I know what the heck I'm doing when I've got a relatively clean beaker in a lab environment. I spend a lot of time tinkering with elicitation methods in the lab, and then I take them out into the field rather than trying to debug things when you've got all the confounds of a field environment. But I do want to have interfaces, and I'll show them to you in a second, that are relatively relatively understood by less formally literate subjects. Very often people kind of say that poor people in developing countries don't understand risk. That's not true. They don't use the risk calculus that we use. They don't use the language we use to describe it. They fully understand risk perfectly well. The difficulty is in representing it in a way that they actually understand rather than in some of the concepts that we use. Another point I want to stress here is that very often these methods are agnostic, in a good way, about risk preferences. So in other words, I don't have to assume EUT or rank dependent or prospect theory or disappointment aversion or regret theory when I'm inferring beliefs. That's not built into the elicitation method, and it's not for some of the other methods. I'm not saying others do, but there are some methods that presume if somebody is an EUT or a rank dependent utility decision maker, that's built into the elicitation. I can remain agnostic about that. The reason is everything I'm doing now for the last 15 years is at the level of the individual. So I'm interested in eliciting Artie's risk preferences, and I'm eliciting his beliefs, and then I go over to Mohammed and I do the same thing. So I'm not presuming that you guys have the same type of model in terms of risk preferences or beliefs. And I like that agnosticism. The bad news is that it requires some structural theory to infer beliefs, and I think this is my answer to Chris's question, that absent some statement about what was the decision-making process that led the subject to report this belief or that belief, and I'll show you the interface in a second. I know I'm sort of putting the cart before the horse. Absent some statement about a theoretical statement, you can't infer anything back. So that the inferences about the latent distributions are conditional on the structural theory that's assumed, and that's, I think, my answer to your point. So if we have problems with that structural theory, that means we have problems drawing inferences, but I think that's entirely proper. I think that's a good thing to explore. Bad news to some people who are lazy is that this requires more econometric work to infer latent beliefs. In other words, you can't just elicit beliefs, get the results from the subjects and go, there's your true belief. You have to do a bit of work afterwards. Frankly, if you guys can't, not you personally, but if y'all can't do it, then it's 6 lines of code. Your graduate students can do it, okay? I know a lot of people don't like doing any econometrics. I've actually had some people, I've had Uri Gnesi, I'll name names. He says, oh, it's a flaw in an experimental design if the design doesn't tell you exactly the answer you need. Well, he's wrong, that's stupid. There's a lot of latent things. If I'm interested, for example, in your relative risk aversion coefficient, and I'm going to assume your EUT, I may have to do some estimation on the work to infer that and get the standard error. So I'm interested in the latent structure because, and this is again my answer to Chris, I'm using a latent theoretical structure to infer beliefs and infer risk preferences. So I don't see this as a problem, and it's actually these days pretty trivial. And it may, and here's the ultimate finger wag, it may require some parametric functional forms. But we have very flexible functional forms. I've done semi-parametric estimation. I've done non-parametric estimation of the utility functions, of probability weighting functions. But guess what? That doesn't generalize to when you've got lots of outcomes and lots of probabilities. You just run out of degrees of freedom. And you end up with extraordinarily low power when you're doing semi-parametric and non-parametric methods. So just live with it. We've got flexible functional forms. If anything I'm saying rests on the functional form, I'd be astonished. But I just want to say that and move on. Okay, the second methodological point I want to make is on source dependence and domain-specific preferences. And my comments about the evidence for this, because I'm actually going to assume source independence. And I know there's folks in the room that would like to disagree with that. That's fine. I frankly don't believe there's evidence for source dependence. And I have a prior here that is diffuse. In other words, I don't have strong priors on this question, but I just want to state that. I've got this written up somewhere if someone cares about it. So I am going to assume, and this is the big assumption here, and I'm making an assumption, and I'll show it to you in a moment, of source independence. And I'll explain exactly the sense in which I'm using that term later. There's a lot of data, hypothetical data, it deserves quotation marks, of domain-specific preferences, that my risk preferences over money is different than my risk preferences over health. I don't believe anything that comes from hypothetical surveys. Frankly, if you do, you're simply not reading the literature. Okay? Having said that, I'm actually perfectly okay if people start with some hypothetical survey questions, establish ideas, and then if you think they're important, for example, utility loss aversion, do them with real rewards. If the only way you can get a lambda that's greater than 1 is with hypothetical tasks, I'm a wee bit suspicious. Frankly, I'm more than suspicious. I think it's bogus. If the moment you take that task and you do real rewards, and I'm just using one example here, it disappears, then I reckon that's a fragile result. And it is. So having said that, there's a lot of hypothetical data that you have domain-specific risk preferences. My priors are that you should have that. I mean, in other words, I don't expect my risk preferences over money to be the same as my risk preferences over health risks, which is the major topic I'm spending a lot of time on now. Having said that, it's not a critical issue just immediately here, but it will become an issue when I'm starting to elicit beliefs over things such as health risks. Yeah.
For stoning the pond, I think that most of my decision making is hypothetical, meaning that before getting to any conclusion I get into it, I do 1 million of fake scenarios with dancers and things in my brain, and then I get
Dancers? Okay.
But,
Yeah.
I'm sure you get what I mean.
How much will I pay for this stripper? Is that the question? I'm missing.
No, what I'm saying is that most part of my introspective decision making is based on hypothesis.
Absolutely. And in fact, when I'm interested, and I am interested in eliciting the process of your decision making, I want to get into that. I'm interested in, I think of it as a behavior, as a homotopy, actually, a path-following method when there are different path followings. I'm completely interested, but your point's quite right. These are all counterfactuals in the sense that I'm not actually pressing the button, so to speak, or paying the money. There's an end result of this, and that's what economists typically spend our time just characterizing the end result. So most of our theorems are about the end result. That's where I want the real data. But you're absolutely right. If my interest is, and it is on another day, actually not right now, in the process and modeling that algorithm, I think of it algorithmically, then you're absolutely right. And I need other types of elicitation methods to get at that, which I don't have yet. I want to do that, but I don't have those. But I take your point. Okay, so all I'm saying is I have strong beliefs that there are domain-specific preferences. Mohammed, yeah.
Yeah, should I understand that we reject the alleged support for source dependence as something that say that your methods are not immune to potential source dependence?
Correct. If, in fact, somebody showed evidence of, I'll show you the assumption of source dependence independence in a minute. It's quite clear. And what I'm saying is that's an assumption. And I was always taught, from my teachers, if you make an assumption, put your hand up and keep your hand up. It'll get tired because if you make an assumption, you put your hand down, people sort of forget the assumption is there. So that assumption is there. I'm conceding that. What I'm saying is the evidence, which some of you have generated, I simply don't believe. That's a separate discussion we should have over alcohol and pleasant conversation, but not right now. Not right now. Okay. I also just want to make a quick point here, and it's something we chatted about, Chris, yesterday, that there's also a case that you have to reject domain-specific preferences and source dependence for normative evaluations. And I'm just raising that issue, that very often, even if we think source dependence and domain-specific preferences are empirically realistic, even if we do, for normative purposes, we may have to reject that. I'm just tossing it out that very often the assumptions we make for normative purposes are not the assumptions that we make for positive descriptive purposes. And that sort of is a little shocking to some of a behavioral background, but I just want to note that point there and move on. Okay, let's get into it. So here's an example. One of the things that we've done is, in the old days, and there's a beautiful McKelvey-Palfrey paper in Econometric and other places when they're doing quadratic scoring rules, at Caltech they'd give them long tables. If you report this, here are the payoffs, and there'd be like mountainous tables of numbers. And subjects are not understanding that. They're not going to understand that. One of the things that we do, which is very modest but makes a huge difference to subjects' comprehension, is give them sliders. Subjects love sliders. So I have movie versions of these I could send to you, but this is a case of a quadratic scoring rule being applied to elicit events over a binary event. A ping pong ball is either orange or white. The subject moves the slider here to report their probability. As the subject moves, these payoffs vary. So in other words, and they vary according to the scoring rule, in this case, the quadratic scoring rule. So what the subject sees is they're moving their report and they see the changes in the payoffs. So that's all. In the spirit of Savage, you could think of these as being in percentage points. If you do these in percentage points, you could think of these as 101 bookies aligned along. That would be the language that Savage would use here. And each bookie is offering different odds on the true outcome. So it's exactly the same analogous there. So subjects are moving this, they're seeing these change, and they basically choose a report where they're willing to trade off the returns here and the returns here. And this is the trainer that we do, by the way. So we don't pay quite that much, but we do play. When we move to, here's the idea of eliciting, and here's where we can explain the sense of source dependence. We have a series of tasks, first of all, where the subject is eliciting their preferences over objective probabilities. I'm using P for objective probabilities and pi for subjective. So this is a standard task for the moment, and everything I'm doing generalizes beyond EU. For the moment, let me just put up EU. We can write out the expected utility of the left lottery in this way if we just had two outcomes, and we typically have more than two outcomes, but that's not important. Similarly, if we have a subjective probability task defined over pi, that's this task. So in other words, this task is where they're choosing between two lotteries, a standard task. This is the task, this SEU is what's driving their choices here. So it's pi that's generating their choice, the pi over this event, 1 minus pi for that event, that's generating their choices as to where to adopt the slider. What we can do is, so I've got some choices here, some choices here. I can jointly estimate pi and the utility function under SEU, okay? Or I could jointly estimate pi, the utility function, and a probability weighting function under RDU. Generally, by the way, when I do a PWF, it's the two-parameter Prelec function, not constrained. I use eta and phi, for those of you who know the parameters, to be both non-negative. If you constrain phi, I think it is, to be between 0, 1, you're imposing inverse S, which is not what people do. I'm sorry if that's shocking to people. They just don't do it. That's not a critique of CPT at all. There's nothing in CPT that requires that people use inverse S weighting as an empirical matter. They just don't do it as the modal response. That doesn't really matter. That's just, I'm just letting you know, because there's a lot of people kind of, for some reason, think that. So you can jointly, yeah. Sorry?
You may not do it in your data, but you do see it in a lot of places.
Not in any data that I've collected. No, I see it in some individual subjects, but maybe 10, 15% of subjects, and I've done subjects all over the place. So let's talk about that some other time. I think, having said that, this is something that psychologists do a lot. They often think the theory is the theory plus specific parameterizations. It's like, you know, their theory is they're like their toothbrush. They're carrying it around as their personal one. To an economist, CPT, rank dependent, is not invalid if people use a power function instead of an inverse S. That's kind of the silliest, that's not you're saying this, but that's kind of the silliest criteria for determining if a theory is valid. Anyway, so I'm just saying we can estimate these. What we do is we get first order effects of risk aversion on recovered subject probability under SEU or rank dependence. So it makes a huge difference. This is discussed in this paper here. I'm just going to move on immediately to the case that's more interesting now. Oh, I've got an important aside here. There's an old technique due to Cedric Smith, binary lottery procedures, basically where people can play for points, and your points earn you probability of a big prize, big M, when 1 minus that probability of a small prize, little m, okay? In so doing, you will effectively risk neutralize the subject. This has been much maligned and derided by experimental economists. I just want to let you know, we've got a paper where we actually reviewed the literature. This is with respect to objective probabilities here. And it turns out that most of the derision is not justified. I use this method for actuaries and for some experts. I don't use this method in general simply because there are too many nasty, nasty, nasty people who dogmatically believe that the binary lottery procedure doesn't work. And they're not interested in studying the data. I'm just letting you know it does work under certain circumstances. I'm just alerting you because if it works, it actually bypasses a lot of these issues that we're dealing with here. We've also applied the same method dealing with binary lotteries. So this is the subjective probability case. Anyway, back to this is the main event. This is the main event, is to elicit beliefs over a continuous event, elicit distribution. So here's the paper that describes the interface and most of the initial theoretical results. So what we're doing, and I'm going to be focusing for now on discretized distributions. Everything here generalizes to having 20 bins. We call them bins, 5 bins. You've got to have more than 2, but it generalizes. All of the theorems in the paper I just showed you and the one that's supporting my talk today, we have proofs of the finite discrete case and also the continuous case. So everything is completely consistent between those. Let me explain how this works. Again, you've got sliders. The subject has 100 tokens. They get to allocate the 100 tokens by moving these sliders. There are 10 bins here. Again, I'm showing the payoffs here from a quadratic scoring rule. So as you vary the sliders, these numbers will change. We have labels here. So the question here is, what's the official unemployment rate for everyone 16 and over in the United States as of February 2013? And usually what you say is, we're going to take the answer from the Bureau of Labor Statistics. So there is a number there that we're going to reward you for at the end. So there's a true answer. The true answer is what the BLS said it was. Okay, so I'm not going to get into those issues. Here's a bin that says it's between 0 to 1.9%, 2% to 3.9%, 4%, and so forth. And it goes up to about 15% or more. So you can vary the labels yourself, however you want to do them. You make them smaller, you can make them wider, depending on the circumstances. And the subjects then vary there. So this is the initialization where they've got 0 allocations. Here's an example where they might have reported a non-degenerate distribution. So that's the kind of thing we're going to see in a moment, okay? You can also report a degenerate distribution if somebody has a belief that it's definitely in here. But this is the typical quadratic scoring rule trade-off. Right? If I put 100 tokens here, notice I get $50. That's the good news. The bad news is if I'm off by, you get paid. Let me back up. You get paid according to the payoffs of the true outcome. Forgive me. Maybe that's obvious. So here, if you're right, you get $50. Wacky-do. That's great. But if you're just marginally wrong, how confident are you, punk? In the Dirty Harry sense, you get 0. So what you might do is say, I'm not entirely confident, so I might move back to allocating a few tokens, leaving a few tokens either side. The quadratic scoring rule handles that pressure. Basically, intuitively, the quadratic scoring rule is always leaving some rewards in reserve to encourage you to be as confident as you can be, but that's up to you to make that trade-off. And of course, that depends on your risk preferences. So that's where risk preferences play a role in distorting your beliefs. Here are some basic theoretical results. Some of them are pretty intuitive. This is just a numerical example just to illustrate the point. If people are risk neutral, and we've known this is a known result from Matheson, Winkler, and others. Here's the true beliefs. This is a case for symmetric distribution. People will truthfully report the belief under SEU. Okay? So I'm not assuming any behavioral errors here. This is just straight theory. Straight theory, we know this. The interesting question is, what happens if you have some modest risk aversion? So just for argument's sake, I'll have the CRA utility function. This is the 1 minus R divided by 1 minus R. So this is modest risk aversion, 0.65, an average sort of number. Here's what we get. There are 2 sort of obvious results here. They're obvious theoretically, but they're worth noting. The first result is if you put 0 weight on some outcome, you will never report a positive weight there. It makes perfect sense if you put a 0 weight on it. This also generalizes, by the way, to rank dependent if you've got any weakly monotonic probability weighting function, not surprisingly. So it's a nice general result. Second result, and this is the key one, if you're risk averse, what you do is you flatten your report relative to your true beliefs. Makes perfect sense, because if you're risk averse, let's stay in the EU world right now just to get the logic going. What do you want to do? You want to equalize your payoffs across states of nature, right? There are 1, 2, 3, 4, 5 states of nature here that you assign positive probability to. So in the extreme, you would report equally here. If you're extremely risk averse, that gives you the same probability across these various states of nature. That was the same logic that led you to report 0.5 in the binary event case. Okay? So notice you're reporting a little bit lower than your true belief here, and you're reporting a bit more here and a bit more here and a wee bit more here. But here's the interesting result. Here's the interesting result. As you go from risk neutrality to by lab standards, significant risk aversion, you're not, let's say, even this is very high by lab standards, you're not getting a dramatic difference in the reports. Now, we can actually tell you exactly how much the difference is. So I'm just saying there's a strong result here that if you're in this sort of world, 0.65, 0.5, which you see a lot of subjects at, then there's not much of a distortion. Importantly, if you assume a symmetric distribution, you'll always reliably elicit the median and the mean. Now, that's a strong assumption, but I'm just saying under that assumption you will. So we have a large number of results there about the importance of risk attitudes. Let me get onto the specific paper here with Eric. What we do is we go that step further. We're going to say, can we recover the true beliefs, and it's true conditional on the model that people are using to form these beliefs and to report them. Under SEU, we need to know the utility function. RDRDU, we need to know the utility function, and PWF. We show in the paper that you can, where if we've got 10 bins, as we call them, you need to solve a system of 10 equations, which is relatively straightforward. And what we do is write this out under a rank-dependent utility specification. You can do it under CPT. It's not that difficult to do. Here we don't use joint estimation. We use calibration. So it's stuff you can do in Excel or Mathematica. And I'll explain what you can do in a moment. Or we can do estimation. Here's how you apply this. And this is where you see the source independence assumption very, very clearly. First, we're going to assume that you know the utility function, the PWF, from experiments over objective risk. Okay, so I give you a battery of 50 binary choices. I elicit, and I'm doing this at the level of the individual. I know whether you're a rank-dependent utility person. I can do a simple test that you don't probability weight, in which case it's EUT. So it's very, very simple. Then if we assume source independence for the utility function, so in other words, the utility function in PWF that I've estimated here, I carry down to recover your true latent beliefs. That's the source independence assumption at work. And the question this might be a longevity risk question that we're very interested in. I'm in the Department of Risk Management and Insurance. We do a lot of retirement planning and those sorts of questions. So we ask a question, that sort of person, and we can infer the effects of this utility function and this PWF on the recovered latent distribution. Let me give you the intuition. Let's assume back here that you're an EUT person. And let's assume that you are, I estimate your coefficient of relative risk aversion is 0.65. In which case, if I observed these reports, I would infer these beliefs. That's the exercise. That's what's being done. So given your reports and given some knowledge with the source independence assumption, I'm not trying to hide that, I can infer back what latent beliefs led you to make those reports. Okay? That's the exercise here. And it generalizes to rank-dependent utility. All right. Let me show you some of the results now. This is our subjects. These are p-values for the individuals. This is 65 subjects on the hypothesis test that there's no probability weighting. We use a 10% significance level to classify subjects, and this is a little unusual. Normally we see 50-50. It's about 50% EUT, 50% rank dependent. For various reasons, we estimate these more specialized probability weighting functions as well. I can explain why later, but that's not important. So each individual is typed. At a 10% significance level, I determine you're an EUT person. I need to see significant evidence of probability weighting before I put you in that camp, okay? And then I'll call you a rank dependent, but then I'm armed with your utility function and your probability weighting function. So when I extend this out, by the way, and do CPT, the CPT bar is down around here. That's all I'm saying. Let me show you, and here's the results. This is a particular subject, subject 1 as it happens, and that was that longevity risk question. So it was a longevity risk question for men. If a man lived to be 20, which is the average age of our subjects maybe in the lab, how many more years would he expect to live? That's a critical input to your retirement decision planning, okay? Here, the black lines show the reports. These are the years. The black lines show the reports. If you're an EUT person, Chris, you're subject number 1, you're patient number 1, patient 0 patient, right? This person had a coefficient of relative risk aversion of 0.71. Those are the adjusted reports. So you can see it's consistent with that theorem. There's a very small adjustment compared to reports. This person is actually an RDU Prelish subject, and I'll jump straight to that, in which case, From that belief, I get that report. From that belief, from that report, I infer that belief. From that report, I infer that belief. From that report, I infer that belief, and from that report, I infer that belief. So that's the process that's going on. This person has this probability weighting function, which accidentally looks inverse SE. Okay, but that's the anomaly. I just want to make you feel calm. Okay, so here's what we end up with. We end up with data at the level of each of the individuals. And there's the pool distribution for that sort of question. So one of the outputs of this is you get data at the level of the individual, which is kind of nice. Okay. Here's a good example. Most of my work now, my applied work, is in health risks. Here's an example of a lady and why it's important. Now we're asking the risks of fraction of deaths due to cancers attributed to smoking by women. And the true answer is out here. This is from the CDC. Notice, here are her actual reports. It turns out that she's an RDU Prelish person. So in fact, her beliefs are a lot closer to the truth than if you simply looked at her raw reports. In other words, she's putting more weight on the bin that is closer to the truth. She's not there. She's not unbiased. But no, here's my point. If you simply looked at what she had reported, you would be misled about how inaccurate her beliefs are. Okay, a couple of limitations. I'm running out of time. The standard discussion about hedging within the experiment. There's a large literature in behavioral game theory where you try to elicit beliefs, and the question is if the person's playing the game and eliciting the beliefs, they might throw the game in order to do well on the belief task. That's fairly trivial as an experimenter to do. You bring people in, half of them do the game, half of them do the beliefs, and you separate them out. So that's handleable. An issue which Arnie and others have raised is what if you have stakes outside the experiment? A good example is I barrack for Hawthorn. And I was telling my students, well, they're going to play a game. This is an important grand final that they won. And the student said, well, surely you should bet against your team. I thought, what do you mean? It's like a shocking statement to say. They said, yeah, well, that way, if they win, you're happy because they won. If they lose, you get money. And the students got it. They were right. It was just a simple, that's exactly your result. There's a one-line way to get out of that. Assume separability of payouts, okay? Assume a separable utility function. It's not the fatal flaw that some have claimed it is, okay? It's important to recognize, and in some contexts, separability might not be an appropriate assumption. And that's the example you guys use of a doctor, I think. What's the probability that you're actually engaged in medical malpractice? Well, that makes a difference to my general wealth, and you should take that into account. Source independence, I already talked about that, but I'm being clear about it as some people would see it as a limitation. A couple of extensions now, which I want to get onto because this is the interesting part. We've looked at less educated field populations, so this generalizes. The use of sliders sort of can be done in a more general population. This is looking at black urban poor in Atlanta. We've actually used binary lottery procedures, and we've discussed it here, with very specialized populations, which is nice. And now most of our work is on eliciting multivariate subjective beliefs, and this generalizes. So now we have 25 bins instead of 10. I'm just showing you the general structure. I'm eliciting a morbidity risk, and I'm eliciting a mortality risk. And it's exactly the same theory that applies. The challenge, which we've solved, is how do you display this to a subject in an attractive way? The answer is actually heat maps. You need a third, so heat maps show you the payoffs. So there's a very tractable way now to elicit bivariate risks, and we haven't got on to trivariate risks, but this is important stuff in terms of health risks. Another example we're doing a lot of work on now, LARCs are a major issue in contraception right now, long-acting reversible contraceptives. OBGYNs are pushing them, and policy is pushing them in developing countries. The big issue in health risk is a lot of girls then say, okay, there's no chance that I'm going to become pregnant, and they ignore the fact that there's still an STD risk. And so they engage in practices that generate high STD outcomes. So in other words, what you want to elicit when you're recommending this is the girl's beliefs about these two risks. There are two risks going on here. So a lot of this literature is now moving towards double protection and so forth, but that's why we're interested in eliciting multivariate risks. We can elicit with CPT if we've got conditional on having good estimates. We can elicit with uncertainty aversion models. So for example, I don't think of KMM as an ambiguity aversion model. It's actually an uncertainty aversion. And in fact, David Schmeidler called it uncertainty aversion in his original paper. It's others, for some marketing reason, that called it ambiguity aversion, but conditional on good estimates. So here's an example, and this is, I actually have a T-shirt, What Would Savage Say? So I should get you this, Peter. You would like this one. So imagine, and this is here's the important point when we deviate from SEU. Okay? Imagine 4 people who are otherwise the same, but they have different beliefs. This person has this belief about this belief, this belief, this belief. Under SEU, of course, they collapse them all to the average. So this is what bothered David Schmeidler, it bothered others. It seems implausible that these people, or even the same person but armed with different beliefs, would do exactly the same thing. So what uncertainty aversion models do is they move away from the reduction of compound lotteries assumption, which is being embedded in here. And so we have estimated, for example, KMM type models, because what we're able to do is we can elicit this thing, but how do I turn it into the latent beliefs? Conditional on something like a KMM model, I can do that. That's what we're doing. Hypothetical bias and the power of prayer. I've said enough about hypothetical bias, but if you do this hypothetically, you get distorted results. That's all I'm saying. So it's yet another demonstration. Hypothetical bias is real. If you claim that there's no such thing as hypothetical bias, I have reached the ugly stage, because I'm old, where I'm saying you are either lying or you're ignorant of the literature. You can choose which. I've written survey papers for 30 years on hypothetical bias. I understand why people want to claim it's not there. I get that. It's cheaper. You might get papers done that you wouldn't get done otherwise. It's just wrong. By all means, do it and say, I'm trying stuff out. But if you want to really believe in Lambda, Peter, then by God, do it with real rewards. And then I'll actually be convinced.
What about if you want to measure things you can't incentivize?
Good question. I'll answer it later after time. No. Actually, let me answer a good question. What if I want to ask about Chris Starmer's longevity risk? That's hard, right? Because you've got a moral hazard problem here, right? You might croak yourself early just to make money on the quadratic, not really, but let's say it's something that, so maybe I want to elicit your beliefs. That can be done in a way you can approximate that with real reward. So what we've done in Denmark is, I say, what if I take somebody who's a male, who's your age, your formal education, all of these attributes that you have, what do you think his longevity risk is? And I know that from the registry. So I'm getting someone who's arbitrarily closer to you. I'm approximating. You may have some idiosyncratic knowledge that I'm not capturing. So I take the point, but anyway. All I'm saying is generally, don't sort of hide under a veil of hypothetical responses. That's all I want to say generally. And sometimes you have to. You don't have to for losses. That's all. We've applied it to risk managers. I'm finishing up now. We're looking at a lot of work in explaining behavior. We've got, for example, we're seeing these results in Denmark. We can recruit criminals in, arguably slow and stupid criminals who've been caught, so there is a sample selection bias. We recruit criminals in. We see the same risk preferences, the same time preferences as controls. Their beliefs differ. And we're seeing this repeatedly when we look at households versus individuals. So the beliefs turns out, to my view, to be one of the key factors that's differentiating a lot of people's behavior. We've done an application of this to measure literacy, and I'm in the last minute or so, and I'll skip over this issue. These are the 2 papers I alluded to earlier in the psych literature. I teach behavioral finance, you talk about overconfidence. Finance people have no clue about overconfidence. They yap about it all the time. They've got lots of papers. They're just plug ignorant. These 2 beautiful papers in psych explain it very, very nicely that you need to elicit a distribution to talk about overconfidence. Finally, on Bayes' rule, here's a test of Gerd Gigerenz's idea that if you simply give people, instead of giving them testing Bayes' rule with a probability format, you give them probabilities, you give them natural frequencies. Here's a heroin question. It's one of the questions that he looked at. So you're seeing with natural, the true answer is 0.05. You're seeing you're in the right direction, but the true answer is here. So even though natural frequencies head you in the right direction, they're certainly not a panacea as Gerd and others have claimed. Okay, conclusions. 1 minute. Give me 1 minute because it's the last slide. Basically now, we have a tool to elicit belief distributions. I'm putting my hands up about the assumptions. I'm getting on with real applications, to be quite honest. I'm interested in other elicitation methods, and I'm happy to study those, but I've got applications I want to get on with. And big extension now is to look at bivariate beliefs. We've got a lot of obvious applications and a few unexpected ones. The costs I've already talked about. So let me leave it there, and thank you for your patience.
Thank you. Thank you. One short question and one short answer.
It's kind of a two-stage procedure plan. First eliciting preferences and then eliciting beliefs. I presume you couldn't do a one-stage thing because of identification.
Yeah, actually, it's two-stage only in the exposition. The subject does two tasks. We jointly estimate using full information, but they're doing two tasks. You're absolutely right. You can do all of the examples of doing these things where you embed in eliciting risk attitudes. This has been done in time preferences, particularly Andreoni Springer, are a disaster of the first order. They complicate subjects. Subjects don't get it. Artie's procedure for eliciting beliefs, it has the same problems. I mean, it works in theory, it just doesn't work in practice. That doesn't mean it shouldn't work. And for some subjects, like actuaries and chief risk officers, these more advanced methods can work. But I would much rather have several tasks which subjects happily go through and then knit them together myself. But you're quite right, there is this knitting together. It would be nicer if the mousetrap would do what you wanted in one clap. I get that. But you can't do it practically with subjects, although I'm interested in studying those mechanisms.
If you have additional questions, I would suggest that you take the opportunity of the
Yeah.
break to ask questions.
Good. Thank you.
Thank you.
And I'll just